Hello, 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 hello. Hello, dear students. Welcome back to my YouTube classes. Hello, hello. Am I audible and visible to all of you? Am I visible and audible to all of you? Yes. That's great. So, as you know that we are dealing with EMI, and today we will be discussing the second last lecture of EMI. Okay. So I hope that you got everything now from my previous classes. So today we will be dealing with the last class, second last class. And this class is very important because in this class we will be discussing some very important things, right? Like emotional, EMF, all these things we will be discussing in this particular numeric, in the particular lecture. Okay. Okay. So I guess my screen is visible to you now, right? So I can write here. Lecture number 9 is second last lecture. It is second last lecture. Tomorrow we will be completing EMI. Then from Monday we will start AC. Okay. So you need some days to, no, to relax. So I'm just giving you these days. Once. Okay. One second. Okay. So let's start today's topic without any delay. So what we are having now, we are having motional EMF. Okay. Today class is my motional EMF. Motional EMF. A good topic and important one. Okay. Be in the class. Okay. So you can write here motional EMF means we are getting the EMF generation. EMF generated due to motion of conductor. So what we are having? We are having a conductor and my conductor is in the motion. Due to this particular motion of my conductor in my magnetic field, we are getting the EMF generated. Okay. So let us suppose we are having a magnetic field. This cross indicates magnetic field is inside or into the plane. Cross particularly indicates that my magnetic field is inside the plane or into the plane. So what this cross indicates? Cross indicates my magnetic field, it is inside. Done. Now, so we are having my conductor. Suppose this particular thing that I'm just creating now, this particular thing is a conductor. This is conductor, right? And this conductor is in motion. This conductor is in motion. So this conductor is in motion. I will write here V. What is V? V is a motion. One condition that you need to think about that my magnetic field which is inside, it is perpendicular to my velocity of my conductor, and L means it is a displacement vector, or L is the length of my conductor. So these should be perpendicular to each other. Okay, the thing is magnetic field B, which is inside, velocity is going in this direction, and my length is in L. Then suppose we are having a particle positive here. This positive is a particle. Okay, here look, my positive particle and my magnetic field is inside. Velocity is in this way. We know that if my particle is in the motion, we are having the magnetic force. Magnetic force is equals to Q V B sine theta, or I can write it, my magnetic field is F equals to Q V cross B. So you can take your right hand towards the V. So V is in the rightward direction. Now curl your fingers in the direction of B. Look, you can take your fingers like this now. Okay, curl your fingers in the direction of B. So where your thumb is upward. So you can write here, sir, my magnetic force is upwards. So can I write now here, sir, my force will be upwards Fm? Okay. So what will happen now due to this? Now, positive charge will accumulate here and negative will be there. Hello, beta. So positive will be upper side, negative will be lower side. If you can zoom this one now, look, I will just show you now. Look, we'll just zoom it now. Look. So positive is upwards, negative is downwards. So you can write, sir, you can write now. You can write Fm is upwards. Now look, positive is here, negative is here. I guess my electric force will be in this way. Why? Because my electric force which is Q times E. Okay, it is from positive charge to negative charge. I guess we know it. Now. Done. Psychomechanical, I will just call you, okay? After my class, I will just call you. Don't worry about anything, right? So here what we are having now, so we are having charged particles. Okay. So look, so this particular figure, this is equivalent. Look, below we are having -1, upper we are having +1. So I can make it like this. It will act as a battery. Positive terminal now, -1. Okay. So we can assume here, sir, here this is a resistance here. A resistance. Current will flow from positive axis, positive side to negative side. Done. So one more important point is, so if you are looking for the resistance, so my current will flow from high potential to low potential. But if we are talking about this rod, my current will flow from low potential to high potential. Think about it. Done now? Think about it. And this, we are having EMF, though this EMF will be VBL. Sir, what is E? E means induced EMF. E means induced EMF. V means velocity of your rod. Done. B means magnetic field. L means displacement of length. Displacement. Done now? Now I will show you the derivation of it. Okay. Now I will show you derivation part of it. Done? Look now. So how many forces we are having? Sir, we are having two forces. Look, if we are talking about this particular charged particle, how many forces are being acted on it? So two forces. One force is upward, that is magnetic force. One force is downward, that is electric force. So at equilibrium, I guess at equilibrium, what I can say now, I will say that my force, magnetic force will be equals to my electric force. What is my magnetic force? Is it Q sine theta? Electric force is Q times E. So I can just cut Q and Q. Yes, sir. What is sine theta? Okay, I will write here. This theta is, it is angle between V and B. So look, V is rightwards, B is inwards. I guess theta is 90 degree now. So what is sine 90? Sine 90 is 1. Is 1. So I will write here VB sine 90 degree, that is E. I will write VB times E. I will write VB times E. From electrostatics, okay, I will write here. From electrostatics, I guess we are having one relation, that is E equals to V by L. E means electric field. V is potential. Here, instead of V, I will write E. L is L. So instead of V, what should I write? I will write VB equals to, is it E by L? So therefore, we are having now E, induced EMF equals to VBL. So this was my derivation part of it. This is my derivation. Done. This is my derivation. Easy? Easy or super easy? Huh? Easy, right? Okay. So this was all about the motional EMF. Basic cause is the charged particle is facing a force due to which they get accumulated at a one end. So we are having a positive charge, negative charge, right? So we are having two terminals of the battery. So this rod will act as a battery. Okay. Look now. So can I write now one thing that, look now. I will make one thing now. So this is my rod. This rod is inside the uniform magnetic field. And the magnetic field is inside. Uniform. What we observe that this side becomes positive, this becomes negative. We will just add one outer resistance to my circuit. Okay, so current will flow in this particular direction. It will flow from high to low potential outside the battery, but inside this rod it will flow from low to high potential. We know it very well now. Okay, velocity is in this way. What is E now? Sir, E equals to BVL. What is I? Current. Current is equals to E by R. What is E? E is BVL by R. Okay, this is induced EMF. This is induced current. Any confusion? Do you have any confusion about this particular topic? Is there any confusion about this particular topic? This is a very important one, right? Very important problem. And I am just making these things very easy to you. Very easy, no? Extremely easy to you now. Okay, so I guess if you are just paying attention to my class, so before starting of this derivation, we conclude that my magnetic field should be perpendicular to my velocity of the rod, and this should be perpendicular to the displacement vector of the rod. This condition, it should be fulfilled. Vaishnavi, physics, chemistry. Is it not better easy? Is it not easy for you now, Vaishnavi? Okay, so we just think about that this particular condition should be fulfilled. Okay, now beta, look now. If let us suppose we are having a rod now, suppose we are having a rod. Okay, rod length is L, that is displacement is L. Is it L? Velocity is in this way, and the magnetic field B is inside. So you can say here, sir, my velocity of my rod, this is parallel to the displacement vector. This is parallel to my displacement vector. So I can write the E, induced EMF will be 0. My induced EMF will be 0. Why? Because we know that we are having the derivational part. No? Look, we are having F now, that is QVB sine theta. Theta is the angle. If it is parallel means 0 degree. So my F came out to be 0. So I cannot write anything then. So E is 0. So three conditions you need to know. First condition, if my velocity is parallel to my length. Second condition, if my velocity is parallel to my magnetic field. Third condition, if my magnetic field is parallel to my length. In these three scenarios, every time my induced EMF is 0. In these three things, my induced EMF will be 0. So you will tell me, sir, look, if let us suppose they are just at 90 degree angle, so we are having VBL. They are at 0 angle, so we are having 0. What if they are just between 0 to 90 degree at any different angles, right? 45, 37, 15, 27, at any angle. What we can do now? What we can do now? Look now, beta. Look now, very easy, very easy, very easy. If, look, if B is cross and it is uniform. If it is cross and uniform, okay, and my rod, this is my rod. One second, beta. If I am having my rod, okay, this is my rod, and this rod, the length of the rod is L. Okay, magnetic field is inside, but this rod is going with angle theta. Angle theta. How to write E now? How to write E now? Sir, very easy. Very simple and easy. How? Look, if V is at any angle, so we need to split this V, or it is component form. This would be V cos theta. One more component will be here, that is V sin theta. Look, beta. If we are talking about V sin theta with L, I guess both have angle 0 degree. So we cannot take this angle now. Okay. Look here. V cos theta L. I guess V cos theta is having 90 degree with L, and V cos theta is having 90 degree with BX. So can I write now E equals to VBL, original formula, but we are not having V, we are having V cos theta. So I can write V cos theta B times L. This is how we can write my motional EMF. I guess these things are very easy to be get in your mind now, very easy. Only thing is you need to know the previous concepts, previous things. Okay. So one more thing, sir. What is the L? What is L? So L. Let us talk about L. Let's talk about L. If suppose we are having a rod, now this is my rod, any general shape wire L, and this rod is having velocity V. Magnetic field is inside. How to write E now? We know E equals to VBL, but L we don't know now. So what we can do? Look, we will just what we can do now? We will just connect these 2 points. This would be the displacement of it. We can just connect these 2 points only. Okay, done. Or if V equals to D, so I can write E equals to VBD. D is the displacement between the wire. D is the displacement between the wire. It is very easy to get it, no? VBL, V is velocity. Okay, if velocity is in component form, how to deal with it? Okay, sir. B. I guess from previous 2 chapters we are dealing with B only. Done, sir. What is L? L is the displacement vector. How to get displacement vector? It is like this, right? Only. Okay. So we are having a lot of ways to get this deal off, right? So let's suppose we are having a rail problem. You might find these things in your book, no? The rail problem. Rail problems. I hope that you are very aware, no, of these things. Very much aware of these things. Okay, if you are, then you can just comment me, no? Sir, we are, right? So it is basically we are having a rails, small tracks like this. It is not getting good. 1 second, beta. One, two. Done. Now here we are having a resistor with resistance R, and we are having magnetic field which is inside. Cross means B is inside. B is inside. My B is inside. Okay. So I'm just writing everything, and I hope that you will write each and everything with me. Now, if you are not capable of writing everything, so you can just go my Telegram channel. You will find the notes of my handwritten notes, right? Don't worry about anything. Now look, if I am placing a rod here, this is my rod. Okay, this is what my rod. Done. Done. No? And if it is, we are just moving this rod with velocity v. If we are just moving the rod with velocity v, one more thing is there now. Okay, what will happen to this rod now? Sir, if rod is there, if my rod is there, magnetic field is inside, length of the rod is L, it is going with velocity v, there will be a current inside the rod. Why, sir? Because this side will be positive, this will be negative, current I will flow through it. No, before that we discussed it. Yes sir, current I will flow through it. I can write current I will flow through it. Now look, if we are having a rod, inside the rod current is flowing, and we are having external magnetic field, there will be a magnetic force Fm. Done. Is it BIL sine theta? I guess before 2 classes we discussed this formula. Yes sir, if we are having a rod, through this rod current is flowing, and we are having external magnetic field there also present. So there will be a one force, magnetic force, which is BIL sine theta. Okay, done now. Look, now we are having a rod, current I is flowing through this particular direction, velocity is in this way, magnetic field is inside. So what will be the direction of Fm? Okay, what will be the direction of BIL? Take simply your right hand, fingers, direction of current, curl your fingers in the B, thumb will give direction of magnetic field. So I can get Fm in this way. Now look, my particular thing is going, my rod is going in this velocities in rightwards, and we are having a force backwards. So what will happen to this rod? What will happen to this rod? Sir, my rod will what? Retard. There will be a retardation of my rod. I'm just merging concepts, right? If a particle is going in one way and forcing being applied in different way, there will be a retardation. We know it very well. Look now, you can see this is initial. If x distance is apart, we are having my rod. Now this, let's suppose, is my final, no, final is x1, this is my x2. Done. Can you write now? I guess area is increasing. Is my area increasing, yes or no? Yes sir. Area na, initially the area is this much. Initially the area is this much. Now you can see the area is this much. So area is increasing. Area is increasing. So I can write, sir, flux. Flux will increase. What is flux? Is it BA cos theta? Done. So I can write BA na, cos theta is 90, cos 0 is 1, that is BA. Done. What is phi? BA. What is A? Area of loop. Is it length? This loop, na, this loop. Is it length? Length is L. L into breadth is X. LX. Is phi equals to BLX? Yes, sir. According to the Lenz law. Or I can write, if don't not Lenz, so we can write Faraday's law also, right? Faraday's law of EMI. My induced EMF equals to d phi by dt. Yes, sir. d by dt. What is phi? Phi is BLX. E, right? Look, B is constant outside, length is constant rod outside. Now I can write dx by dt. And dx by dt is V. I can write induced EMF of motional one is BLV. One more proof to your formula is it BLV. One more proof. Okay? If you want these things, you can write these things. Couple of ways to get these things done. No? Okay. Now, if let us suppose you are having a numerical, right? Look, my particle is going in this way. Okay, with let us suppose some constant velocity. Now we are applying a force backwards. So you can see now my velocity gets decreased. Velocity gets decreased. Now, let us suppose if somebody will ask you what should be the extra force. What should be the extra force that you need to apply to this particle toward the right side so that its velocity should be constant. I will repeat my thing, right? You can see my rod is going rightwards, but there is a force leftwards. So what will be there? Retardation. My question to you is, what should be the minimum force that you should apply on this rod so this rod will be in constant velocity motion? How we can write it now? How we can write it now? Sir, my magnetic force Fm, is it BIL sine theta? Yes, sir, it is. It is, right? So look now, what is B? Sir, B is B. Done. What is I now? Induced current. I guess I have given you the value of induced current now. I. What is I now? This is I. I is BVLR. I can write I is BLV by R. And angle, it is sine 90 degree. And sine 90 is 1. I can write Fm came out to be, is it B square LV by R. So this should be your extra force. This is your extra force. Okay. That you need to extra, so V becomes constant. If you need velocity to be the constant, this is the extra force that you need to apply. Simple as it is, no? Yes or no? Huh? Yes or no? No, there is L also, now look, there is L also. So there is L square. Easy, beta? Easy or super easy? Easy or super easy? Easy or super easy? I guess super easy, no? If you are having any doubts, no, you can just let me know. If you are having any doubts, you can just let me know, no? Okay, now look beta. If we are applying some extra force, so I guess there should be a power delivered by the extra agent also. Applying force, displacement is there, so there will be a power also. Okay, so how to deal with power? So can I write here power, about the power? I will write here power delivered by external agent. Power delivered by external agent. So what is power? Is it force into velocity? What is force? Is it V square L square V by R into V? Can I write equals to B square L square V square by R? Yes. So we can apply now. Daksh is there, right? Daksh, after a long time, now you are not in the class from previous couple of days, I guess, right? So B square L square V square by R. Done. Easy, super easy, or ultra easy. Look, beta, if let us suppose you have not done your 11th class in a very good way, now, so you cannot recall the power, this thing, right? FV. If you are not good with the electrostatic, you cannot do anything with these chapters, no? Everything is related here, right? Everything is related. It is not that I will just go in one lecture and I will just get everything. No, it is not just like that. Okay. Look, let us do a one numerical that was asked back in some years in IIT, right? In IIT, we are having a semicircular ring like this, a semicircular ring, right? And this semicircular ring, this side is X, this side is Y. Magnetic field is inside B, and this thing is going in this way with velocity V. Velocity V. Done. And it is radius. If you're talking about radius, radius is given as R. So how to find it is motional EMF. Sir, I guess motional EMF, the formula is BVL only. Okay, sir. B is B, velocity is V given. What is L? L is displacement. So I guess you need to take the displacement like this now. Yes, sir. If this is R, this would be R. So I guess total length of this thing would be 2R. Yes, sir. So I can write instead of L 2R. So my answer came out to be, sir, 2BVR. Answer. This one is my answer. Now, if somebody will ask you, determine, action numerical, na? Determine high potential and low potential. How to get high and low potential? Sir, I will make a rod like this. A rod like this. Okay, length of this rod is 2R. Okay, velocity is V. B is inside. To get the high potential, let us suppose we are having a positive charge here. This one. Take your right hand. Okay, V cross V. V is downwards. Okay, B is inside. So where my positive will go? Take your right hand, no? Take your right hand. Elephant, yeah. Take your right hand. Where V is going? So downwards, take your hand downwards, right? Where is B? B is inwards. So your thumb goes towards the right. So that simply indicates, sir, my positive charge will accumulate here, negative will here. So this will indicate high potential. This will indicate low potential. So what will be the direction of current? What will be direction of current? First option, is it from Y to X? Second option, or X to Y? What will be the direction of current? I'm just asking you now. Direction of current, is it Y to X or X to Y? I'm just hoping that you will give me a good answer. No? I will just wait for your answers. Take your time. I will just wait for your answers. Huh? Yes. So Y answer will be, is it X to Y or Y to X? Do you know why I just asked you this numerical to you? No? Do you know why? Look. Every time now, if we are talking about the rod here, I will specify it. If we are talking about the rod, current will flow from Y to X, low potential to high potential. I know now that every student is giving the wrong answer to this numerical, right? You know why? Look now, if this is my battery, suppose here we are having a resistor R. We know that current will flow through it, no? Look. So if we are talking about this resistor, current will flow from high potential to low potential. But if we are talking about this battery, current will flow from low to high, na beta? So this particular rod, it will act as a battery. Look here, it will act as a battery. So current will flow through this one as like this. So my current will flow in this way. Done. So my current will flow from low to high potential. This thing you need to keep in your mind. A very good thing and very interesting thing also, right? Easy or super easy? Amita? Super easy, no? So look, if you're just watching some class, no, you will get something you will get, no? If you're not 100%, but something you will get, right? Okay. Let us do one more numerical. One more numerical, a different variety now. Okay, and a good one also. If we are having a uniform magnetic field here, if we are having a uniform magnetic field like this, B is like this, and inside this we are having a loop. We are having a loop, and a loop is moving with the velocity v. Side we are having A, B, C, D. It is a square, and the length of the square is given as L. What should be the value of E? What should be the value of E? Motional EMF. Sir, let us think about it. How many approaches we are having? Sir, one thing that we know, V is equals to BVL. One approach. Can you see now flux is constant? Can you say here the flux is constant? Why? Because it is inside the field. No? Flux is constant. So if flux is constant, what is delta phi? Delta phi is 0. If no flux is changing, so E will be 0. Okay. Second approach. So can I write E equals to VBL? Yes, sir. What is L? L is displacement. If we are talking about the loop, right? So that L is 0. Displacement of the loop is 0. So E will be 0. Second approach. Third approach. Let us talk about, this is my loop like this now. Done. This side L, velocity is V, S side L, L, L. Look, this velocity, this side, angle is 0. Yes, sir. This velocity, this side, angle is 0. Yes, sir. So this side, no EMF, this side, no EMF. But let's talk about these two things now. So we know that, let's talk about plus charge here. So plus will be here, negative here. Plus here, negative here. So it will act like this now. E, E, both EMF now. So let us use KVL. I can write minus E plus E is 0. Is 0 answer? So we just completed or conducted a single numerical in 3 different ways. So you are having, no, look, if you are very well to know all these concepts, you can use only one concept, no matter. Only that one which should click you in the numericals part or in your examination part. You can do it. Done? Okay. Let us talk about the different types of numericals. If we are having an infinitely long wire, current I is flowing, let us suppose, and here we are having a rod. This is my rod. Rod velocity is V. Magnetic field is inside. Rod length is L. Okay, done. What is B? This B. B is nu naught I divided by 2 pi d. You can see here, if this is D now, right? So this D is increasing, that B is changing. So you can write, sir, B is changing. If B is changing, flux is changing, so there will be EMF. We know it very well. Okay, sir. But what will be the value of EMF? E equals to BVL. What is B? Is it nu naught I divided by 2 pi d? That instead of V, I will write V, then L. So my answer came out to be nu naught I V L divided by 2 pi d. Easy or super easy? Or ultra easy, no? Easy, super, or ultra easy? Easy, no? Everything is very easy to you now. Huh? Look now. One more numerical, a different type now. Look. We are having an infinitely long wire. But my rod is in this way now. This is my rod. Velocity of this rod is in this way. The distance of this first end is A. Length of the rod is L. Find E. Can we write E equals to VBL? Can we write like this? No, sir. Can we write like this? No, sir. Do you know why? The reason is, look, if we're talking about this particle, different distance, right? Each and every particle on this rod is having different distance from this rod. So B is different now. B is different now. So if something is doing in this way now, so we have to go x distance and take an element of dx. Every time we need to just do like this. Go towards x and cut an element of dx. Okay, and we know this procedure from the 11th standard. 11th. Same numerical we discussed in our electrostatics, where we need to find out charge density, right? Lambda now. I hope that you know it, no? In first class, I guess we discussed that part, right? Okay. So what will be the small, on the small part, what should be the EMF? Sir, I can write D. Is it VBL? It is V or BVL, no issue. Okay, what is B now? B is nu naught I divided by 2 pi x. Done? Yes, sir. V is V. What is L? L is length of that part. Is it dx? Yes, sir. But I don't know, need small, I need big one. Big one, I will integrate it. So dE will become E now. Integrate from A to A plus L. I will write A to A plus L. Nu naught constant, yes sir. I constant, yes sir. V constant, yes sir. 2 pi constant, yes. Integrate from A to A plus L 1 by x dx. Integration of 1 by x is ln of x. So I can write nu naught I V divided by 2 pi. It is ln of x. Upper limit is A plus L, lower is A only. So I can write E equals to nu naught IV divided by 2 pi ln of A plus L minus ln of A. Log A, log B. So I can write E came out to be nu naught IV divided by 2 pi ln of A plus L divided by A. This is my end answer. Okay, I will just write here now. Thank you, beta. Thank you. I forgot to write now that it is present, right? Easy or super easy now? Easy or super easy now? Huh? Easy? Easy or super easy? Easy, right? Okay, one more thing. Suppose we are having a rod. Length L, this thing is theta. B is inside. Velocity is V. Find E. Sir, E equals to BVL. E. B is B, V is B. But what is L? L we don't know. L means the displacement. Nah, just join these two. If I will write it like this now, look, this is L theta, so this will become theta by 2. So what will be this distance L? This will be sine. Look, what is sine theta now, beta? I can write sine theta. P by H perpendicular will be H sine theta. P H is L and we are having sine theta by 2. So this side will become how much? It is L sine theta by 2. So but we are having double of it now. So the whole is, it is plus L sine theta by 2. So I can write here, it is 2 times L sine theta by 2. This is my answer. And this is how you need to do it. Done? Okay, one more numerical. If we are having a semicircular ring, P, Q, B is inside, and velocity is in this way. What is E now? What is E now? Amida, what is E now? What is E now? I want answer from your end. What is E now? I will give you 1 minute now. Just do it. What is E now? What is E now? 0. Yes, it is 0. Do you know why? Look, we know that E equals to VBL or BVL, no issue. And I just told you that if V is parallel to L, so my E is 0. You can see now. This is my L. So theta is 0. That means both are parallel. So E will becomes to 0. E is 0 now. Okay. So now we know that if this is my rod is going in this way, rod is going in this way, rod is going in this way. Let us suppose I will rotate this rod, then we will see what will happen to it. Okay. Yes, but a length is parallel to the velocity. So next topic is, let us suppose we will rotate or revolve the rod now. Okay. I will rotate this rod now. Rotate. If we are having rod like this, I will hinge this rod. That means here it is hinged. Okay. Hinged means it is fixed at this particular point, right? Done. And we are having magnetic field B. Now we are just giving an angular velocity in this way. Length is L. Length is L. It is doing a rotational motion now. This part is doing a rotational motion now. How to find it now? First thing, and important thing. You need to measure from this end. So take this as 0. Take this as L. Done. Let us take a small element here. Small element. Okay. X distance apart. Take a small element of dx. Look, we know that there is a relation of circular motion. There is a relation of circular motion with the rotational motion. Rotational motion. Each and every particle of this rod is doing a circular motion. But if we add the whole effect of circular motion, that is a rotational motion. We know it now. Look, so I can write one thing here now. What I write now? Look, what I can write here. So what will be the small motional EMF of this particular thing? Huh? Is it E equals to BVL? What is B now, sir? B is B. What is velocity? Sir, I cannot write velocity. Why? Because there is an angular velocity. Is there any relation between velocity and angular velocity? Yes, sir. V equals to omega times R. Done? But what is R? R is here length. So I cannot write B, V, it is omega times X. What is L? Length of that part is dx only. I will integrate it from 0 to L. I will write E equals to B omega. Then integrate from 0 to L, it is X dx. So you can know now that it is B omega. Integration of X would be equals to X square by 2. Upper limit is L, lower limit is 0. So I can write E equals to 1 by 2 B omega square, omega L square. Sorry, it is omega L square. It is omega L square. Easy or super easy? Is this easy or super easy or ultra easy? Now, okay, now identify. I will ask you one numerical that identify high potential and low potential. Sir, for high to low potential, let us suppose we are having a particle plus here. Now it is going upwards v velocity. Take right hand, V cross B, so force will be rightwards. Na? So my positive charge will accumulate here, negative charge will accumulate here. So this will act like this now. Okay? Done? But do you know what is the original formula? Do you know what is the real formula? Real formula? What is real formula? Do you know about it? Look, if we are having this rod, now I will zoom it. If we are having this rod, hinged part, and we are just rotating it with the omega. Let us suppose this part is A, 2 points, huh? This part is B. It is x1 distance apart from the hinged part. This is x2 part, no? Okay. B is inside. So real formula is 1 by 2 B omega. L means displacement. What is displacement? Huh? Is it x2 square minus x1 square? So this is my real formula that you need to apply anywhere. This one is my real formula that you can use anywhere, no? Anywhere you can use it. Okay. Suppose we are having a rod. Suppose we are having a rod. Okay. If we are having a rod, look for this rod. And the hinged part is here. This is my hinged part now. This one. Okay. And distance from this part is L by 4. Distance of this part is 3L by 4. How to write the things now? What is x1 and what is x2? We know formula, na? E equals to BV. It is 1 by 2. BV, V is not, we are having omega here. It is B omega L square. Omega L square. Is it x2 square minus x1 square? Yes, sir. It is like this. It is like this, right? So how to write now everything to us? Huh? Look. X1 and X2 means distance from hinged point to my particular things. I guess if you are very well aware of it. So let us talk about this part. Then let's talk about this part. So what I can write now? So I guess here my x is 0. Here my x is L by 4. If we talk about this part now, here my x is 0. Here my x is 3L by 4. Take separately, na? Take separately. First part is this one. Second part is this one. First part, what is x1? X1 is 0. X2 is L by 4. In second part, x1 is also 0. X2 equals to 3L by 4. Done, sir. Let's write everything to us. No? E equals to 1 by 2 B omega x2. What is x2? Is it L by 4 square? 0 square. So equals to, look, it is B omega L square 4 16 32. This is my answer. Second part now. E equals to 1 by 2 B omega. L is 3L by 4 whole square minus 0 square. E equals to B omega 9L square 32. Second one. So we are having two EMFs here. Then, so look now, beta. Done now? Huh? Done? So look now. If it is 0 point, initial point 0, A and B. Okay. Done? Take your right hand. So if you are taking your right hand, if here is my particle is going upwards. So right, V cross B. So my positive charge will accumulate here. Here is the charge part, it is going downwards now. V cross B. So particle will go here. Negative. So this part V naught is more than VA. Here V naught is more than VB. So can I write VA plus B omega L square by 32 minus 9B omega L square by 32 equals to VB by point potential method from current electricity. By point potential method from electricity. Sir, how did you write this thing now? Look, I can write now. How, sir? Look, I can write this thing now. Look, it is minus. Yes, sir, it is A point minus positive, negative, and B minus positive, negative. If you are going, it is VB. Negative, positive is positive, negative, negative. It is VB by point potential method. So that's why I told you every time, just think about it. Okay, now, okay, one more thing. If we are having a semicircular coil like this, now we are just hinged it and rotate it about this axis. So this would be to our point A, point B. What is E now? 1 by 2 B omega x2 square minus x1 square. So here x is 0, here x is 2r. Can I write now? E equals to 1 by 2 b omega x2 is 2r square minus 0 square. So E came out to be 1 by 2 b omega, it is 2 to the 4 r square. 2 cancel out. So E came out to be 2b omega r square. Done? Okay, one more thing. Numerical. One rod is like this, one rod is like this. Length is L, both are at 90 degrees. We are rotating these things like this by omega. Find E. What is E now? Same 1 by 2 b omega x2 square minus x1 square. Here it is x1, here it is x2. Just connect these two things. L, it is root 2 times L. I can write E equals to 1 by 2 b omega. It is root 2 times L square minus 0 square. So E came out to be 1 by 2 b omega. It is 2L square. 2 to cancel out. So E came out to be b omega L square. Done? Easy, super easy, or ultra easy? Huh? Easy, super, or ultra easy? I guess I am giving the good content now, beta. I am giving a different approach how to do these things now. Easy, no? Look, beta, the only fun is now in the online classes or in the live session, you can just ask me your doubts. No, you can ask me, sir, this how this thing came out. Okay, you can just give me, sir, no, everything understood. Just let's proceed now. Okay. Okay. Now, if we're having spokes, okay, spokes parallel. So, what is the meaning of it? I will just tell you. We are having a rim sort of thing like this, a circular thing like this. Okay. One thing. Okay. So we are having a rod. We are having a rod like this. One rod. Second rod. Third rod. Fourth rod. We are having number of rods, right? Number of rods. Now we are just rotating it. We are just rotating it in this way. Look. In about the this way. What will happen to it now? If B is inside. Let us talk about this particular one, right? This particular one. Velocity is in this way. Done. Length is in this way. I guess positive charge will accumulate here, negative here. One thing. Let's talk about this one. V is in this way. L is same. So positive here, negative here. Same, negative will accumulate here, positive will accumulate here. Negative here, positive here. Negative here, positive here. Negative, positive, negative, positive. I can make it like this now. Look, I can make it like this. Look. Look now. I guess we have done this numerical no? In our electricity, right? Each and every one is E. Look, every one side is connected to this potential. Second part is to this potential. I guess everything is parallel combination. So I can write it like this now. 1, 2, 3. Okay. One side connected to one end, second side connected to second end. E, 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 E. What will be E effective? That is E only. What is E effective? E only. So I can write E came out to be 1 by 2 B omega L square. Easy or super easy? Easy or super easy? Okay, the last numerical of today's class, then we can just end the session. Okay, last numerical. Last numerical is we are having a wheel. Wheel is having 20 spokes. Done. Length of each one is 1 meter. And it is speed. Speed is given as 120 rpm. Done. B is given as 0.4 Gauss. Done. No? Find motional EMF. What is formula for motional EMF? That 1 by 2 B omega L square. Done, sir. It is 1 by 2 B. B is 0.4 Gauss. Gauss means 10 to the power minus 4 Tesla. Omega is 2 pi F. L is 1 square, 1 meter square. Okay. 1 by 2 into 0.4 in 10 to the power minus 4. 2 into 3.14 into F. What is F? F is given, na? So it is given 120 rpm. So I will just multiply it 1 by 60. It will become rps. It is 2. So F came out to be 2 rps. So I can just multiply it with the 2 only, right? So look, 2 cancel out. So it is 4 to the 8, it is 0.8 multiplied by 3.14 10 to the power minus 6. 0.8 into 3.14, it is 2.5 10 to the power minus 4 volt. Easy or super easy? Easy, super easy, or ultra easy? Done? Okay. Easy now? Easy? Yes, beta. Easy? So I will just see your comments now. Super easy, na? Okay. So look now, beta. What I just want to tell you now, that is, one second. Okay. So the thing is, now we just completed 7 or 6 lectures of EMI, 6 lectures, no? So tomorrow, previous question, 1 second, sir. Which one? 1 second. Which one, beta? This one? Is my signal visible to you? This one? This one or the wheel one? Which one? Spokes one or this one? This one now? This one? Okay, you want to write it? Or you want me to just give a more clarification on it, no? So you only need to write it, no? Or you want me to just make you one more time to understand to this problem? Okay, wheel question. Look now. Look now. Look. Suppose now it is not basically wheel problem. Look now. If this is my rod, this is my rod. It is hinged here. If we are just rotating it in this way, so this part will go up, this part will go down. Okay, done. What will happen now? Now, if we are having a positive charge here, So its velocity will be upwards. If you are having charged particle here, its velocity will be downwards, and B is inwards, no? B is inside. Take your hand, take your hand, take your hand. Okay? B is upwards, cross. So thumb is going towards the hinged part. That simply indicates positive charge will get accumulate here, negative charge will get accumulate here. Now about this particle, V is downwards, V downwards, B inside. So my thumb is towards the right, so positive charge will accumulate here. I will just make it like this now. Look, I will just, it is negative, positive, then positive, negative. Can I write like this now? I can make it like this now. So one more rod, it is like this, hinged here, it will rotate like this. I will just make it like this, like this. One more rod is like this. So I will just make it like in this way. Okay. Now you can see now these are overlapping. Now look, these are overlapping. If these are overlapping, so you can see now this particular positive terminal is connected at one end. This negative terminal is attached to one end. So I'll just make it like this now. One end to one common point, second end to second common point. This combination is known as parallel combination. This combination is known as parallel combination. And if you are just got to my class of electric current, so in parallel combination, now if let us say this series, so E effective will be N times E. But if we are talking about parallel combination, E effective is only E, no? That's why I just wrote it is E only. If let us say we are having 20 spokes, 100, 50, doesn't matter, no? E will be same for all of them. 1 by 2 B omega L square. Okay, and now we are done with tomorrow. Tomorrow is Friday. Tomorrow is Friday. Friday we will end EMI. We will end EMI. Then from Monday we will start AC. Okay, so in next week we will start AC, and within 6 to 7 days we will just complete AC plus EM waves. Then AC EM waves, then we will start modern physics. It is modern physics. After modern we will start semiconductors. Then last we will start optics. Okay, this is my plan. Okay, I guess I hope that I need to stick to this particular plan. Okay, and we will complete the everything of the syllabus now before the time that I have given to you. And still, if you want to just ask me anything, you are most welcome. Thank you, beta. Thank you. Bye. Good night. Take care, beta. Bye. Good night.